Hello good people, I'm going to talk about the valence shell electron pair repulsion model. What in the name of the abyssal plane is this? While it does not exactly roll off the tongue, the Vesper model is very useful when it comes to predicting the shapes of molecules. And the three-dimensional shapes of molecules contribute greatly to the properties of compounds. More on that later. For now, I want to explore the Vesper model. Recall that we can think of electrons as particles of negative charge. So each time we have a pair of electrons, we have a zone of negativity. And that zone of negativity will electrostatically repel any other zone of negativity. And so the main idea behind the Vesper model is that the structure around an atom is determined by minimizing the electron pair repulsion. In other words, any bonding and non-bonding or lone pairs of electrons will try to be as far apart from each other as possible. The electron pairs will electrostatically repel each other. Let's see if I can help you visualize this. I'm going to remove this and bring in these 5 diagrams. What do they represent? Firstly, they represent my lack of artistic talent. But beyond that, each red sphere represents an atom, and each blue line represents an electron pair. Keep in mind that these electron pairs could be non-bonding and bonding. The electron pairs are trying to be as far apart from each other as possible, because they electrostatically repel each other. If there are 2 pairs of electrons, the furthest apart that they can be is 180 degrees. The electron pairs form a line, and we call this a linear electron geometry. We can represent this using Lewis dot structures. The X is my atom, and I have 2 electron pairs that are 180 degrees apart. Alright, what happens when there are 3 electron pairs? Once again, the electron pairs are trying to be as far apart from each other as possible. And so, they will end up 120 degrees apart, giving the trigonal planar electron geometry. I can represent this using Lewis dot structures. Once again, the X will stand for my atom, and now I have 3 pairs of electrons. Things start to get really interesting once we get to 4 electron pairs. You might be tempted to arrange the electron pairs in shape of a plus sign, but that would be thinking in 2 dimensions. Our molecules exist in 3. And so this pair of electrons and this one here are in the plane of the screen. The one in the background is sticking into the screen, and the one in the front is poking out of the screen. Again, I am not the best of artists. The point, though, is that these electron pairs are now about 109 degrees apart. And the geometry that we have ended up with is known as tetrahedral electron geometry. This too can be represented using Lewis dot structures. The X stands for the atom, and I have 4 pairs of electrons arranged around it. Moving on to 5 pairs of electrons. Are you thinking 3-dimensionally? I sure hope so. These 2 pairs of electrons are in an axial position. If you like, they're sticking out of the north and south pole. These 3 electron pairs around are in the equatorial position. And now we have 2 angles that we need to worry about. There is the angle between the axial pair and the equatorial pair. That one is 90 degrees. And then there is the angle between each equatorial pair. That angle is 120 degrees. This geometry is known as trigonal bipyramidal. Once more, I can represent this using Lewis dot structures. Again, I have the X representing my atom, and now I have 5 electron pairs around the central atom. So let me draw them in. Considering what we have previously learned about stable electron configurations and the octet rule, this looks rather odd. However, as it turns out, for certain atoms, this is allowed. Moving on to the final diagram and 6 electron pairs. Now we have 2 pairs in the axial positions and 4 pairs in the equatorial positions. They are all equally spaced apart, and the angle between each pair is 90 degrees. This gives the octahedral electron geometry. And using Lewis dot structures, I will have an X, and now I will have 8 electron pairs spaced around the central atom. So here they are. Again, it looks odd, but it turns out for certain atoms this is perfectly allowed. Within this course, we are going to focus on the first 3 diagrams, but you need to be aware of the other 2 as well. In summary, electron pairs, whether they be bonding or non-bonding, will electrostatically repel each other, which means that they will be as far apart from each other as possible. This will influence the molecular shape. More on that screaming horror in a later video. That is all for now, and I will see you on the flip side.